This is question number 54. The question is very simple. Arrange the following elements in order of decreasing covalent radii. Now on the practice test, I've underlined the word decreasing. In order to emphasize that, I could write the same question and say increasing, in which case the order would be reversed that you're going to come up with. And all you're going to need for this problem is to understand the principle that what are the trends with covalent radii. And we already discussed this in the question we just answered, actually number 56 in the sequence, or 55 in the sequence. We had to discuss this topic. What is the general trend as we go across the periodic table in a row? It gets smaller. Why?
Because there's more protons flowing in.
The increased nuclear charge, and the increased nuclear charge over what? What is the common factor all the way across a row? The screening of the inner shell electrons. So for the completed shells, for any completed rows that exist in the lower rows, there is a filled shell of electrons, which, because of the principal quantum number being smaller, have a smaller radius. And so they're held more tightly, therefore they are going to be, there's going to be significant electron density located between the nuclear charge and the valence electrons. And so that provides the same amount of screening all the way across the row, because they all are built on the same shell of filled shell electrons of the lower shells. And so that trend means the same amount of screening exists all the way across the row, but as we go from one element to the next, there is a successive increase in nuclear charges, increasing the number of protons. So what you'll need for the test, and probably will be provided, is a periodic table. Okay? Or there'll at least be one in the room. Somewhere in the neighborhood we'll have one of these. So you can know that general trend is going across a row, and we see it decrease in size. And what happens as we go down? It increases in size because we're going to a larger what? Principal quantum number. Each row corresponds, the first row, hydrogen and helium, corresponds to quantum number n equals 1. Second row, n equals 2. And once we go all the way across the row, we filled that shell. And then we go to n equals 3. So as we increase our principal quantum number, as we found, and that was why we talked about that with the Bohr atom. The Bohr atom suggests that the Bohr radius increases as we increase the principal quantum number. And so that's only going to, the Bohr equation is only going to be worthwhile for 1 electron atoms, but that general trend is also is true. Now there are 2 notable exceptions to this trend in increasing size as I go down. And they are, when I go from aluminum to gallium, instead of seeing it get bigger, it gets smaller. Can anybody tell me why? What's different between aluminum and gallium? See anything? There's there's 10 electrons, 10 nuclear charges, but what kind of orbitals correspond to the transition metals? D orbitals. The d orbitals, let's look at their shape real quickly. This you don't need to write on your board, so this will be on scratch paper. But briefly, let's look at the different types of electrons. This is an s electron, it's going to be spherical. The p electron. So, by the way, just to remind me, what is the angular momentum quantum number here for s? L equals 1 for the orbital angular momentum. I have some sort of dumbbell shaped. Now, this has less electron density near the nucleus, actually none near the nucleus, and so the electron density is further away than in an s orbital. And then we get to the d orbitals, which have generally a cloverleaf shape. And this has even less nuclear density near the nucleus. It's more spatially extended. So what that means is, as we go across the row, as we go across that row, we've got 10 electrons, an increase in 10 in nuclear charges with not the same screening, because the screening requires that the electrons be closer to the nucleus and between the nucleus and the next successive valence electron, which is going to be the p orbital. So what happens is we get what's called the d block contraction, going from aluminum to gallium. There's actually a slight decrease, but generally that's already taken care of for all the rest of them. That d block contraction is just aluminum to gallium. There is another one down here as we go from this row to the next row, and that actually from the second row to the third row. Or not the second row, the 1, 2, 3, 4, fifth row to the sixth row. And it's generally referred to as, like if I go from hafnium or from yttrium or zirconium to hafnium, I'm going to see it get a little smaller. This is referred to as what? If this was the D block contraction, what do you think is intervening here? The F block. So it's the F block contraction, more commonly referred to as the lanthanide contraction. So those are the exceptions. I'm not going to test those exceptions, but I want you to know them. What I'm going to test is just going to be in general. And the biggest is going to be the one that's furthest down and to the left, and the smallest is going to be the one that's furthest up and to the right. So if I want to write this in order of decreasing covalent radii, which is going to be the one that's going to be first? The biggest? The biggest one. And it's going to be decreasing going across. So I'm going to be, in other words, the one that's going to be, I'm going to end up with is going to be the one that's which end of the periodic table?
Top right.
The top right. And so I'm not going to have any weird jumps where I'm going to, in the pattern, where you're going to have to go from one particular group and then down into the right, because that's too weird. So I'm going to be going like this, down, this, down, this, down. So it's only going to be motion in this direction or this direction as I go through the periodic table. So of all of these, which one is the furthest to the left and down? Cesium, exactly. So we will, on the paper, that was scratch paper, on the paper you'd write cesium, and it is larger than, so which one's next in our hit parade? Which one? What's this called? 10. Yeah, because 10 is up 1 and across a whole bunch. So it'd be 10, which is in turn greater than, what's next?
Wrong one.
Oh, yeah, sorry. Thank you. I believe you're looking at, there is no more in that row. Yes, it's up all the way to silicon. It's directly below it. So silicon would be next, which is then going to be not nitrogen. Phosphorus. Which is greater than, now we can go, now we're in the same group as nitrogen. Which is greater than, and we're pretty much out of options. And we ended up with the one that's furthest to the right. So the key to this question is going to be noting what the underlined word is, and hopefully I'll remember to underline it on the test. But whether it's increasing or decreasing, you can expect a question just like this, and it should be a cakewalk. Okay? Are there any questions about this question? Is everybody clear? Okay, that's a wrap.